Hello and welcome to today's class. For today's class on mathematics, we'll be studying the concept of complex numbers. Now, by complex with the numbers, it doesn't mean it's a very hard or difficult thing to do. No. All right. We'll look at what complex numbers are and how we actually solve problems involving complex numbers. First things first, a definition. What's a complex number? By definition, a complex number is simply any number in the form a plus ib, where a and b are real numbers. By real numbers, we mean either positive or negative numbers, and the value of I is equal to the square root of minus 1. All right, so any number in the form a plus ib is called a complex number. Now, before the 16th century, it was difficult to find the square root of a negative term. All right. For instance, if I'm to get the square root of, let's say, minus 4, this would have been impossible. Not until the 16th century. It was in the 16th century that the idea that I should be equal to square root of minus 1 was formed, and hence it gave us the edge or the ability to find the square root of a negative term. How? From here, if I'm to solve this using the idea of SOLD, this will be equal to the square root of minus 4, the square root of, this becomes equal to the square root of 4 times minus 1. So I have this, of course, 4 times minus 1 gives you minus 4. So this is equal to, we can separate these two, square root of 4 times square root of minus 1. From the idea of sorts, this is correct. Okay, this is equal to square root of 2 of 4 is, of course, 2 times root minus 1. And we said root minus 1 is equal to I. So this is equal to 2I. All right, so hence, the square root of a negative term can now be found. Example, the square root of minus 4 is equal to 2I, and this is a complex number. Say I is equal to the square root of minus 1. All right, so that's what a complex number is. Examples of complex numbers includes 2 plus, let's say, 4I. This is a complex number. All right, so observe I'm placing the I after the number. Still okay. Minus 1 plus 3I is a complex number, etc. All right, next up, let's look at the representation of complex numbers. We represent look at representation of a complex number. All right, we represent complex numbers in different forms. The first one is called the rectangular, also called the Cartesian form. That's the first form of representing complex number. In this form, a complex number takes the shape a plus ib, as we said earlier here, or perhaps in bracket a, b. All right. So this is the Cartesian or the rectangular form of representing complex numbers. Example, let's say a complex number z is equal to 2 plus 3i. This is a rectangular or a Cartesian form representation of this complex number. The second form of representing complex number is called the polar or the circular form. For the polar form, a complex number is represented as z being equal to r into cos theta plus I sin theta. This is called the polar form or circular form representation of a complex number, where r is called the magnitude or the modulus of the complex number, and theta is called the amplitude or the angle of the complex number. So this is the second form of representing complex numbers. The third form is called the exponential. We'll give examples of this much more later. The third form is called the exponential or the Euler's form. All right, or the Euler's form of representing complex number. We said for here we have something of nature z equal to r exponential I times theta. All right, so this is the Euler's form of representing complex numbers. All right, so we have our forms or pattern of representing complex numbers: rectangular form or Cartesian, polar form or circular, then exponential form or Euler's form. Next up, let's look at the algebra of complex numbers. How do we add complex numbers? How do we subtract them? How do we multiply? And how do we even divide complex numbers? Let's look at them in the algebra of complex numbers. All right, so let's look at the algebra of complex numbers. For the algebra of complex numbers, we'll be considering the addition of complex numbers, the subtraction of complex numbers, the multiplication of complex numbers, and of course, the division of complex numbers. Let's start with the first one there. Let's start with addition of complex numbers. Addition of complex numbers. All right, let's look at how to add complex numbers. Given a complex number, let's say given two complex numbers, let's say z1 has been equal to a1 plus ib1 and z2 has been equal to a2 plus ib2. If I'm asked to add them, that's find their sum, z1 plus z2 will be equal to, that will be equal to z1 is a1 plus ib1 plus z2 is a2 plus ib2. So we have this. Now, to add or subtract any complex numbers, simply add their real parts and that separately, and add their imaginary parts separately. The real part is simply the parts without I, in this case A. The imaginary part is now the part with the I, that's IB, IB1, that's it. In Z2, the real part is A2, while the imaginary part is IB2. So this will be equal to, if I take off brackets, it becomes A1 plus IB1 plus A2 plus IB2. Take the real part, that's equal to A1 plus this one here, A2 plus, take the imaginary part, IB1 plus IB2. Let's factorize the i's. This will be equal to A1 plus A2 plus, if I factorize I, I'm left with B1 plus B2. I times B1, IB1, I times B2, IB2. All right, so this is how we add, or this is how we take the sum of complex numbers. Let's take a quick example. So let's say a simple example. Let's say Z1 is equal to minus 3 plus 2i, and Z2 is equal to minus 1 minus I. Would have that Z1 plus Z2 is equal to, this Z1 is minus 3 plus 2i plus Z2 is minus 1 minus I. If I take out my real parts, I'm having minus 3 plus minus is minus, so minus 3 minus 1. If I take out imaginary parts, I'm having plus 2i, that's plus 2i, plus minus is minus I. If I work on this, minus 3 minus 1 is minus 4, plus 2 minus 1. So 2 minus 1 is 1. That's a positive 1, so plus I. So my answer becomes minus 4 plus I. So this is how we add up complex numbers. At the end of today's class, I'll leave a link to show you how you can do the algebra of complex numbers using just your calculator. All right, we'll provide the link in the description of this video. But for now, let's proceed with this. Let's look at the second algebra of complex numbers, which is the subtraction. Let's look at subtraction. Subtraction of complex numbers. Subtraction of complex numbers. All right. Let's have Z1 as being equal to A1 plus IB1, and Z2 same thing as being A2 plus IB2. To subtract them is as easy as Z1 minus Z2, which will be equal to that will be equal to Z1 A1 plus IB1 minus A2 plus IB2. All right, that's Z1 minus Z2. If I expand brackets, I have here as A1 plus IB1 minus to this is minus A2 minus plus minus IB2. So we have this. All right, let's collect the real parts, which is A1 and minus A2. So I'm having A1 minus A2. Take the imaginary part, which is plus IB1. So plus IB1, then this one here, minus IB2. Finally, let's factorize. That's equal to A1 minus A2 plus, take out the i's, plus I have B1 minus B2. I times B1, IB1, I times minus B2 minus IB2. So I have this. Let's look at an example. Perhaps let's take the same example. The same example as saying Z1 should be equal to minus 3 plus 2I, and Z2 should be equal to minus 1 minus I. So let's find Z1 minus Z2. That's equal to Z1 is minus 3 plus 2I minus Z2 is minus 1 minus I. So that's equal to, if I subtract this, this gives you, or if I expand the bracket, it gives you minus 3 plus 2I, minus minus is plus 1, minus minus is plus I. Next up, take the real parts and the imaginary parts. This is equal to, for real parts, I have minus 3 and plus 1. For the imaginary part, I have plus 2I plus I. This is equal to minus 3 plus 1 is minus 2. 2 plus 1 plus 3I. So that's your answer. We can still use the formula to get an answer if you want to. If you use the formula, this is equal from the formula there. We'll say that A1, compare this to the formula here, this becomes A1, B1, A2, B2. So if I use the formula, so taking this one off a bit, let's try using the formula. So A1 will be equal to this minus 3. B1 will be equal to this plus 2. A2 will be equal to this minus 1. Also, B2 will be equal to coefficient of I here, minus 1. That's minus 1. Let's fix them to this formula. So Z1 minus Z2 will be equal to, we said A1, that's minus 3, minus A2, A2 is minus 1, okay, plus I into B1, B1 is plus 2, minus, so minus B2, B2 is minus 1. If I work on this, this is equal to, I'm having minus 3, minus minus is plus, minus 3 plus 1 is minus 2, plus I into 2, minus minus is plus, 2 plus 1 is 3. So this will be equal to minus 2 plus 3i, the same value. So you can choose to use this formula if you want to, any of the formula, or you can subtract directly. So this is a simple idea of how you add and subtract complex numbers. Simply add their real parts together and perhaps add and subtract their imaginary parts together. All right, let's look at the next concept, which is the multiplication of complex numbers. All right, so let's look at the multiplication of complex numbers. Before we look at multiplication of complex numbers, let's note something. We said I is equal to square root of minus 1. So if I take I squared, that will be equal to the square root of minus 1 all squared, where this square will cancel square root, and that's equal to minus 1. Okay, I cubed will be equal to root minus 1 cubed, which is equal to root minus 1 squared times root minus 1. Of course, these two will give you root minus 1 cubed, the square of it, and then itself. That means that I cubed is equal to root minus 1 squared, as we've gotten here, is equal to minus 1 multiplying root minus 1. We said is equal to I. That's I. This is equal to minus I. Finally, I to the power 4 is equal to root minus 1 all to the power 4. This can be broken down as root minus 1 all squared multiplying root minus 1 all squared, and that's equal to root minus 1 all squared is equal to minus 1 multiplying root minus 1 all squared is equal to minus 1. Minus 1 times minus 1 is 1. So I to the power 4 is equal to 1. So note these four things. Note that I is equal to root minus 1. I squared is minus 1. I cubed is minus I to the power 4 is 1. So we'll get this down and we'll use them in our solving. All right. I think this is good. All right. So we said I is equal to root minus 1. I squared is minus 1. I cubed is minus I. And I to the power 4 is 1. Let's see how we can use this in solving. So let's say example 1. Example 1. Let's say z is equal to 4 plus 3i. Find z squared. Let's say find z squared. Solution, z squared would be equal to what I have here, 4 plus 3i all squared, which is equal to 4 plus 3i multiplying 4 plus 3i, multiplying itself. That's equal to, we said for multiplication, use the first term in the first bracket, 4, multiply everything in second bracket, 4 plus 3i. Second bracket, use the second term in first bracket plus 3i, multiply everything in second bracket, 4 plus 3i. All right, that's equal to 4 times 4, 16, plus 4 times 3i is 12i, 4 times 3 is 12, bring down the I, plus 3 times 4 is 12i, plus 3 times 3 is 9, I times I is I squared. All right, this is equal to 16 plus 12i plus 12i gives you 24i plus 9 into I squared. We said I squared is equal to minus 1. So that's minus 1. So this is now equal to, I'm having here 16 plus 24i, and then plus 9 times minus 1 is minus 9. If I take out the real parts, 16 minus 9 plus 24i. So hence, z squared is equal to 16 minus 9, that's about 7, plus 24i. So my answer is 7 plus 24i. So this is how we work, or this is how we solve multiplication of complex numbers. We'll take a second example on this, and then we'll move on. So let's take another question on multiplication of complex numbers. So you're given z1 has been equal to minus 3 plus 2i, z2 has been equal to 4 plus I, and z3 has been equal to 5 minus 10i. You have to find the value of z1 times z2 times z3. How do you solve that? Solution. Of course, your first task is to multiply 2 first. I can choose to work on these 2 first. Then with my result, I'll now multiply it with z3. So I'll keep z3 pending, work with just z1 and z2. So z1 times z2 would be equal to minus 3 plus 2i into z2, 4 plus I. So this will now be equal to the first term in the first bracket, minus 3, multiply everything here, 4 plus I. Second term here, plus 2i, multiplies everything here, 4 plus I. So multiply this, minus 3 times 4 is minus 12, minus 3 times I is minus 3i, plus 2i times 4 is plus 2 times 4 is 8. Bring down the I, plus is plus 2i times I is 2i squared. This is I squared, please. Alright, so that's equal to minus 12 minus 3 plus 8 is plus 5i, then plus 2. I squared, we said, is minus 1. So that will be equal to, simplify this first, minus 12 plus 5i plus 2 times minus 1 is minus 2. So if I take the real part, minus 12 minus 2, the imaginary part, plus 5i. Minus 12 minus 2 is minus 14 plus 5i. This is the value of z1 times z2. Finally, let's now add z1 times z2 times z3. So that will be equal to the result of z1 and z2. We have it as minus 14 plus 5i multiplied by the result of z3, that's 5 minus 10i. Alright, so we go again. That's equal to first term here, minus 14, multiply everything here, 5 minus 10i. Second term here, plus 5i, multiply everything here, 5 minus 10i. This is equal to, if I multiply this, 14 times 5, I'm having minus 70. Okay? So minus 14 times 5 is minus 70. Minus minus is plus. Minus 14. So minus minus is plus. 14 times 10 is 140i. Plus plus is plus. 5 times 5, 25i. Plus minus is minus. 5 times 10 is 50. I times I is I squared. So I have this. Okay, so this is equal to minus 70. 140 plus 25 is plus 165i minus 50 into I squared. We said is minus 1. So this is equal to minus 70 plus 165i minus minus plus I have 50. Separating the real part from the imaginary part, my real parts are minus 70 and plus 50. Imaginary part is plus 165i, and that's equal to minus 7 plus 50 is minus 20 plus 165i. That's my answer. So this is how you do multiplication of complex numbers. Finally, we'll now look at the division of complex numbers. All right, so let's look at the fourth one called division of complex numbers. Now, when it comes to dividing complex numbers, before you do a division of complex numbers, you have to have an idea of what is called the conjugate of a complex number. Let's consider something called conjugate first before we dive into the division of complex numbers. Let's look at the conjugate of a complex number. Now, given a complex number z being equal to a plus ib, the conjugate of this complex number z is written as z bar. All right, so z with a bar on the head. All right, z bar. And z bar, the conjugate is equal to a minus ib. So when it comes to getting conjugate, the idea is simply I'm going to change the sign of the imaginary part only to the opposite sign. So hence, let's say z is equal to, let's say 3 minus 4i. I will have that z bar is equal to 3 plus 4i. I am only changing the sign of the imaginary part. Finally, if z is equal to, let's say, minus 3 minus I, we'll have that z bar, which is the conjugate of this. Let's call this z asterisk to separate this on here. So z asterisk bar will be equal to minus 3 plus I. So please take note that when it comes to when it comes to conjugate, I am only changing the sign of the imaginary part. The real part is left the same way. All right, having this in mind, let's see how we do division of complex numbers. We'll take an example and explain this. Let's say I have 3 plus 2i dividing 2 plus 3i. So this is a division of complex numbers. The idea is this: it is improper to leave a denominator of a fraction as a complex number. It's not proper. So in cases like this, where I have the denominator of a fraction as a complex number, what do? I'll have to rationalize, just like the same ideas with sorts. So I'll have to rationalize rationalize. What do I mean by rationalization? For rationalization, I'm multiplying numerator and denominator by the conjugate of the denominator. So it becomes numerator, that's this, multiplied by the conjugate of denominator, 2. This becomes minus 3i. Do the same thing here, it becomes 2 minus 3i. So this is what is called rationalization of complex numbers. Multiply numerator and denominator by the conjugate of denominator. So 2 minus 3, I have this. So multiply this, what do we have? This will give you first term here, 3, multiply everything here, 2 minus 3i. Second term here, plus 2i, multiply everything here, 2 minus 3i, all over first term here, 2, multiply everything here, 2 minus 3i, second term here, plus 3i, multiply everything here, 2 minus 3i. So I have this. All right, let's expand this and see what we have. This will be equal to, so that's equal to 3 times 2 is 6. 3 times minus 3i minus 9i. So 3 times minus 3 is minus 9. Bring down the I. Plus 2 times 2 is 4. Bring down the I. Plus times minus is minus. 2 times 3 is 6. I times I is I squared all over 2 times 2 is 4. 2 times minus 3 is minus 6i. Okay. Plus 3 times 2 is plus 6i. Plus times minus is minus. 3 times 3 is 9. I times I is I squared. So work this out. This is equal to, I'm having 6 minus 9i plus 4i gives you minus 5i minus 6 into I squared, we said, is minus 1 all over, I'm having here as 4 minus 6i plus 6i will cancel out. That will give you 0. I'm left with minus 9i squared is minus 1. So this will be equal to 6 minus 5i minus minus plus 6 all over. I'm having 4 minus minus plus 9 times 1, 9. So this will be equal to, I'm having, take this and this, that becomes 6 plus 6. And then that's the real parts, imaginary parts, minus 5i all over 4 plus 9, that's 13. This is equal to 12 minus 5i all over 13. So this is my answer. So that means for this, I will separate them, becomes 12 over 13. So I'm having 12 over 13 minus, I'm having 5 over 13, and then I have I. All right, so this is how we do division of complex numbers. So observe that the denominator now is no longer a complex number. It's just a real number. So I have this. You can now separate this. So this is how we solve problems on division of complex numbers. We'll take some other examples and then move on to something else. All right, so we'll end the division of complex numbers doing this example. All right, so we'll end the division of complex numbers doing this example. I'll do question 1 and you do question 2. All right, so the question says, express the following in the form 1 plus I all cube all over 2 plus I. So solution, number 1, I'm given 1 plus I all cube all over 2 plus I have this. My first task would be to simplify this. This would be 1 plus I cube. I want to use the binomial expansion formula, in which if I use binomial expansion formula, it's a cube plus 3ab squared plus 3a squared b plus b cubed. We've discussed this in our previous class, binomial expansion. I'll leave a link to this binomial expansion in the comment section. So just check, sorry, in the description of this video, I'll leave a link to binomial expansion. Or perhaps you could just go through our playlist for mathematics and you see the video on binomial expansion. So if I use this concept here, a is 1, so it becomes 1 cube plus 3 into a is 1 into b squared. B is now I, so it becomes I squared. This I squared. Okay, so here's 1. Here's 1 plus 3 into a squared. A is 1, so it becomes 1 squared times b. B is I plus b cubed. That becomes I cubed. If I work on this, this is equal to 1 cubed is 1 plus 3 times 1 is 3 times I squared. We said I squared is minus 1 plus 3 times 1 squared is equal to 1 times I plus I cubed. So I have this. All right, so this is equal to 1, 3 plus times minus is minus, 3 times 1 is 3 plus 3 times 1 is 3 times I is 3I plus I cubed, that is equal to minus I. So this is equal to 1 minus 3 is minus 2, 3I, so plus 3I plus minus is minus I. If you simplify this, that's equal to minus 2 plus 3 minus 1 is 2I. So I've gotten my answer. So this is like a faster approach on how to expand this. So it's better you learn how to use binomial expansion instead of having to multiply this one itself thrice. That's way longer. So it's better you learn how this is done. I'll leave a link to the video lesson on binomial expansion in the description of this video. So you can check the description of this video for the lesson on binomial expansion. Let's proceed. So it means that all of this numerator is now this. That's minus 2 plus 2I all over denominator 2 plus I. So we have this one here. What's wrong here is that my denominator is a complex number, and we said it is improper to leave the denominator of a fraction as a complex number. So in this case, what do? I'll have to multiply both numerator and denominator by the conjugate of denominator. So multiply this one here, multiply this by the conjugate of this, that becomes 2 minus I all over, multiply this by its conjugate, 2 minus I. So I have this. So this is now equal to, use the first term, minus 2, multiply everything here, 2 minus I, use the second term, plus 2I, multiply everything here, 2 minus I, all over, use the first term here, 2, multiply everything here, 2 minus I, use the first term here, plus I, multiply everything here, 2 minus I. So I have this. Alright, so this is now equal to minus 2 times 2 is minus 4. Minus times minus is plus. I have the 2I. Plus times plus is plus. 2 times 2 is 4. Bring the I down. Plus times minus is minus. 2I times I is 2I squared all over 2 times 2 is 4. 2 times minus I is minus 2I plus I times 2 is plus 2I plus times minus is minus I times I is I squared. So we have this. Alright, to work this out, this is equal to, I'm having here as minus 4 plus 2 plus 4 is plus 6I minus 2 into I squared. We said I squared is minus 1 all over, this is 4 minus 2 plus 2, they will cancel out, minus I squared is minus 1. So minus I squared is minus 1. We have this. So this is equal to, I'm having here as minus 4 plus 6I minus minus plus 2 all over, this is 4 minus minus plus 1. I'm having plus 1 there. This is equal to, take the real parts of the numerator, minus 4 plus 2. Take the imaginary part of numerator, plus 6I all over, 4 plus 1 is 5. That's equal to minus 4 plus 2 is minus 2 plus, I have here as 6I all over 5. So I can now separate them. So it means that 1 plus I all cubed all over 2 plus I will be equal to, separate these two, it becomes minus 2 over 5 plus 6 over 5I. So I have this. Right, so this becomes my answer. So this is how we solve this question. Please solve the B part and leave your answer in the comment section. All right, I'll give you a reply if you're wrong or you're correct. Okay. All right, so that's how you solve this question. Let's move on to the next thing there.